Hello students, now we are going to have a detailed demonstration of process synchronization, and this is Nithyapriya. These are the contents of our presentation. We see about process synchronization, then we see race condition, then the critical section. Okay, so process synchronization. Process synchronization is that is if more than one processes try to handle or try to have one single processor, there the process synchronization concept will be included. Okay, so synchronization is when two or more processes are being handled out hand in hand, how they are using the resources of a computer. Okay, if process 1 is allowing, then only the process 2 will be using that resource. If process 2 releases the resource, then only process 3 will be using the resource. Okay, so that is how the resource can be used. Not all the processes can handle a single resources at the same time. Okay, so there should be a mutual understanding among all the processes being running in a single system. So this particular concept is known as process synchronization, right? So on the basis of synchronization, the processes are handled, the processes are categorized into two types. One is independent process, another one is cooperative processes. There's no problem with independent process because they are exclusive processes. Okay, so there will be no connection between or no system sharing between the processes running. But in case of cooperative processes, the execution of one process will surely affect the execution of another process. So this is called as cooperative process. When cooperative processes are being handled in a system, then only the process synchronization problem occurs. Right. So in synchronization, three concepts are involved. Okay. So we'll see that here mutual exclusion, progress, and bounded waiting. So there is a condition called race condition. Race condition is when a particular process, for example, when P1 process 1 is executed and it is using when process 1 is executed, at the same time simultaneously process 2 will also be executing in the same processor, right? If that particular, if both the processors if want to handle a particular resource, okay, there will be a competition between these two processes about which can take the particular resource first. For example, any IO device, okay, a printer, okay, for example, if both the processes want the printer to be used, which process will get printer first? Process 1 or process 2? Or in which basis that will be supplied, the printer will be supplied to the processor. So that is called as race condition, right? So the resource may be any, it may be an IO device, it may be the memory, okay, so that may be any resource in the computer, right? The competition between two or more running processes in getting the same resource is called as race condition, right? Then critical section. So critical section is actually a code segment that can be accessed by only one process at a time. Okay, so that is called critical section, and this is the picturization of critical section. So entry section, then there is critical section, then exit section, then remainder section. About critical section, the critical section contains shared variables that need to be synchronized to maintain the consistency. Okay, so the shared variables means how to say, the variable that can be shared. Okay, so I already told you when there are concurrent processes, then only the mutual exclusion comes. Okay, process synchronization also comes when there are two processes that are independent. There is no need to talk about this process synchronization and mutual exclusion. The same way, in the critical section, there are variables called shade variables, and these shade variables, the problem arises because of this shade variable, because shade variables can be shared by more than one processes. Okay, the critical section contains these shade variables, right? Okay, then, and there are two sections in this critical section called entry section and exit section. In entry section, the process requests for entry to the critical section. Okay, and in the exit section, the process is exiting out of the critical section. Okay, so the entry point is called entry section, and the exit point of the process is called as exit section. Any solution to the critical section problem must satisfy the following three requirements: mutual exclusion, progress, and bounded waiting. Right. So, what is mutual exclusion? Mutual exclusion is, it is exclusively for a process. Okay, you know the meaning of this, I think. If the process is executing in a critical section, no other process can enter in. Okay, so that is it, called mutual exclusion. So only by in mutual exclusion, using this mutual exclusion, we can handle the problem of process synchronization. Okay, if a particular code, or if a particular memory, or if a particular IO device is used by a process that is being currently executed, no other process can use the resource. So that is called mutual exclusion. If the resource is released by the current process, then only any other process which is waiting can access the resource. Okay, so this is the condition of mutual exclusion. So by this process synchronization can be handled. Then progress. Progress is, if the critical section, in the critical section, if the currently running process is exiting, it comes to the exit section. Then there are many process wait on the for the critical section outside the critical section. Okay, so which process can be allowed in? So that will be decided by the processes that are not participating in the critical section. See, there is one process executing inside a critical section, and there are so many processes waiting outside, and there are also processes which are outside the critical section. Okay, now the current process inside the critical section is over, and any one of the processes which are waiting can be taken in to the critical section. So which process can enter? This can be decided by the processes which are outside the critical section. So this is called progress. So first process 1, then the outside process will decide which of the waiting process can be in. So process 2, for example, is in. After process 2, the outside process will decide which can be the next process 3. So process 3 will be in. So this is called as progress. Then bounded waiting. Bounded waiting is, the number of time is limited or confined. Okay, so that there is a time bound for all the processes waiting for the critical section. If the time bound is not there, many of the processes will be waiting indefinitely. Okay, so the waiting time will be infinite. So to avoid this, the processor itself will set a time bomb for the processes which are waiting outside the critical section. Okay, so here we mean the time bomb of the waiting time for the waiting processes. Okay, so that is all about process synchronization. Here we saw, shortly we saw process synchronization. Then we saw about the critical section and race condition. Then the three requirements for handling the critical section. Okay, so that's all. Thanks for watching. I hope you understand.